So hello, good afternoon to everyone. Okay. Hmm. Oh, okay. So in the last lecture, we had learned the molecule with two similar or dissimilar chiral center. Okay. So okay, so these are the example of molecule with two similar or dissimilar chiral center. Okay, this star indicates the chiral carbon. So this structure 1 and structure 2, these are the example of molecule with two similar chiral center. These are the example of what? Molecule with two similar chiral center. And this 3, 4 and 5, 3, 4 and 5, the structure 3, 4 and 5, these are the example of molecule with two dissimilar chiral center. Okay, but because the chiral center is different. Okay, while in the first one both the chiral center are same. This here chiral carbon, this chiral carbon attached to OH, COH and hydrogen, same this chiral carbon attached to OH, H and COH. Okay, so this is the example of molecule with two similar chiral center. Okay, and while this structure number 3, it is the example of molecule with two dissimilar chiral center. Okay, because the chiral center is different. Here this chiral carbon attached to your bromine, methyl group and hydrogen, and here this chiral carbon attached to OH, CH3 and hydrogen. So both the chiral carbons are different. The molecule with two dissimilar chiral centers. So this is what we had learned in the last lecture. So again in the last lecture we had learned the diastereomer. What we had learned? Diastereomer. So stereoisomer that are not mirror images of each other. Stereoisomer that are not mirror images of each other are called as diastereomer. Stereoisomer that are not mirror images of each other, that is called as diastereomer. So here this structure 1 and structure 3, okay, these are the what? Diastereomer of each other, because these two 1 and 3, these two are not mirror images of each other. Okay, while this first and second and 3 and 4, these are the mirror images of each other. Okay, that's why this first and 2, this is called as enantiomer, because these are the non superimposable mirror images of each other. These are what? Non superimposable mirror images of each other. Same this 3 and 4, 3 and 4, 3 and 4, these are what? This is called as enantiomer, because this structure number 3 and 4, these are non superimposable mirror images of each other, while this first and third and your second and fourth, okay, these are what? Not this first and third and second and fourth, these are not mirror images of each other. That's why they are called as diastereomer. That's why they are called as what? Diastereomer. So you know that this diastereomer having a different chemical and physical properties, and it having a different melting point, boiling point and solubilities. Okay, so that what we had learned in last lecture. So again in the last lecture we had learned the enantiomer and diastereomer. Okay, that is difference between your enantiomer and diastereomer. Okay, so the difference between is first difference between is what? This enantiomer, they are non superimposable mirror images of each other, while this diastereomer, they are not mirror images of each other. ठीक है, enantiomer are non superimposable mirror images of each other, while diastereomer, they are not mirror images of each other. And second difference between point is in enantiomer they have same physical and chemical properties. Enantiomer having same physical and chemical properties, while diastereomer, they have different physical and chemical properties. They have different boiling point, melting point and different solubility and different solvent. Okay, then the third point is they rotate plane polarized light in the same extent but in opposite direction. Okay, so enantiomer rotate the plane polarized light in the same extent but in opposite direction. Okay, one rotate on right hand side while other rotate on left hand side. Okay, while this diastereomer, they may or may not rotate the plane polarized light. Okay, they may not be optically active. They may or may not be optically active. So they may or may not rotate the plane polarized light. Then yeah, yes. Okay, so the third point is enantiomer rotate the plane polarized light in the same extent but in opposite direction. Okay, so enantiomer are optically active. They rotate the plane polarized light in the same extent but in opposite direction. It means that one rotate on right hand side and one rotate on left hand side. While this diastereomer, they may or may not rotate the plane polarized light. It means that this diastereomer may or may not have optical activity. Okay. Then the fourth point is this enantiomer, they cannot be separated by physical method. You can't separate this enantiomer by physical method. Okay. While this diastereomer, you can separate this diastereomer by physical method, because it having different melting point, boiling point, and different solubility. So depending upon that, you can easily separate this your diastereomer. But this enantiomer, it having same physical and chemical properties. Okay, same solubility, so you can't separate it by physical method. Okay. Then this enantiomer are optically active. It means that this enantiomer have ability to rotate the plane polarized light. Enantiomer having ability to rotate the plane polarized light. It has the ability to rotate the plane polarized light. While diastereomer, okay, this diastereomer may or may not be optically active. Okay, they may or may not optically active. So these two are the enantiomer of these are the pair of enantiomer. Okay, so these two pair are non superimposable mirror image of each other. These two having same physical and chemical properties. These two rotate the plane polarized in a same extent but in opposite direction. One rotate on right hand side and other rotate on left hand side. It cannot be separated by physical method, and these two are optically active. Okay. Now this diastereomer, these are the two structure of diastereomer. Okay, so these are not the mirror image of each other. They have different physical and chemical properties, and they may or may not rotate the plane polarized light. And you can easily separate this diastereomer uh, by physical method. Okay. And this may or may not rotate plane polarized light, and they may or may not be optically active. Okay, so this is the just a revision what we had learned in the last lecture. Okay, now let's move towards the next slide. Okay, so students, today I am going to teach you the mesostructure or meso compound. Okay, so the meso compound means a molecule with two or more chiral carbon. A molecule with two or more chiral carbon atom but have a plane of symmetry is called as mesostructure or meso compound. Okay, or you can say that the compound having two or more chiral carbon but passes the plane of symmetry, that compound is called as meso compound or mesostructure. Okay, that compound is called as meso compound or mesostructure. Okay, so these are the example of meso compound, because now this compound having two chiral center. This is chiral center 1 and this is your chiral center 2, but it passes the plane of symmetry. When you pass the plane through this molecule, it divides into two equal parts. It divides this molecule into two equal parts. That's why this molecule is called as what? Meso compound or mesostructure. Okay, so a molecule with two or more chiral carbon atom but have plane of symmetry, but it passes the plane of symmetry, is called as mesostructure or meso compound. Same this compound number 2, uh, it having these two chiral carbon. This is your chiral carbon 1 and this is your chiral carbon 2, but it passes the plane of symmetry. That's why this is also your mesostructure. Then this is your compound number 3, it having what? Two chiral center, but you pass it when you it passes the plane of symmetry. Okay, that's why this molecule is also meso compound. then this is your fourth one. Okay, so same, this fourth compound having two chiral carbon 1 and chiral carbon 2, but it passes the plane of symmetry, but it passes what? Plane of symmetry. That's why this four compound is called as meso compound or meso structure. So a molecule with two or more chiral carbon, a molecule with two or more chiral carbon, but also have a plane of symmetry, but also have a plane of symmetry, is called as meso compound or meso structure. These molecules have a plane of symmetry, and that divide them midway between the two asymmetric chiral center. That what divide the molecule midway between the two asymmetric carbon. So these are the two asymmetric carbon and divide this molecule into, okay. And now what you notice that what this half of the molecule is the mirror image of each other. When you cut this molecule, this half of the molecule is mirror image of this half part, okay. And both the molecule now what this your meso compounds are optically inactive. Meso compounds are what? Optically inactive. They can't rotate the plane polarized light, okay. Although it having two chiral center, but it passes the plane of symmetry. That's why these meso compound are optically inactive. Meso compounds are optically inactive. They don't have ability to rotate the plane polarized light, although it having two chiral center. That's why this molecule is called as meso compound. Okay, they neither rotate the plane polarized light, okay. And this optical inactivity is due to internal problem, okay. This optical inactivity is what? Due to internal problem, because the optical inactivity is due to you can say that internal compensation. The optical inactivity is due to internal compensation because your problem is in structure, okay. That's why it's a internal problem. So optical inactivity of a meso compound, it is due to internal compensation, okay. Internal compensation because it passes the plane of symmetry. And you know that in the last lecture we had learned the what element of symmetry, that is plane of symmetry, center of symmetry, and alternating axis of symmetry. So the molecule which passes any one of the symmetry from these three, okay, that molecule will be optically inactive. Okay. So this meso compound passes the plane of symmetry. That's why these are optically inactive, and the optical inactivity is due to internal compensation. Okay. Now this is all about your mesostructure. Again, I am explaining what is mesostructure. So mesostructure or meso compound, a molecule with two or more chiral carbon atom but have plane of symmetry is called as meso compound or mesostructure. These molecules have a plane of symmetry dividing them midway between the two asymmetric chiral carbon in each. Okay, and you notice that half of the molecule is the mirror image of other, okay. And this mesostructure are optically inactive. They can't rotate the plane polarized light, and this optical inactivity is due to what? Internal compensation. Is what? Due to internal compensation, because the problem is your structure. Problem is internal, okay, because it passes the plane of symmetry and it's the internal problem. So this meso compound having optical inactivity, and this optical inactivity is due to internal compensation. So this is what about your meso compound or meso structure. Now let's move towards the next slide. Okay, that is in this slide will teach you that is new point, that is racemic mixture. Okay, racemic mixture. Now what is meant by racemic mixture? Okay, or it is also called as a racemic modification. So this racemic mixture means, the definition of this racemic mixture is a mixture of equal parts of enantiomer. A mixture with equal parts of enantiomer is called as racemic mixture or racemic modification. racemic mixture or racemic modification. A mixture with equal parts of enantiomer is called as a racemic mixture, or you can say that equimolar mixture of plus and minus form of your compound is called as the racemic mixture. It is a equimolar mixture of two components. Okay, it's a equimolar mixture of two components, or you can say that a mixture of equal parts of enantiomer. A mixture of equal parts of enantiomer is called as a racemic mixture. It is called as a racemic mixture. It means that consider you are having one beaker, and in one beaker you are having 10 ml of your half percent of your lactic acid, and half percent of your plus lactic acid, and half is your minus lactic acid. Okay, it means that mixture is called as racemic mixture or racemic modification. So to understand what is racemic mixture, okay, so first let's see this, what is this your enantiomer. Okay, so this is your pair of enantiomer. Okay, lactic acid, this is your plus lactic acid, and this is your minus lactic acid, plus lactic acid and minus lactic acid. Okay, because these two are the what these two are the non-superimposable mirror images of each other. Okay, these are the pair of enantiomer, and one rotate the light on right hand side and one rotate on left hand side. Plus mean what? Right hand side it's a dextrorotatory. Okay, minus means what? Levorotatory. It rotate the light on left hand side. It having melting point 26 degrees Celsius. Same here, this having 26 degrees Celsius. Okay, it have same melting point and a specific rotation, that is alpha is what? It having 14.1. It means that it rotate on right hand side, and this another molecule having specific rotation minus 14.1. Okay, it means that it rotates the light on left hand side. Okay, it rotate on right hand side, and this one rotate on left hand side, and these two separate are the optically active. This one is also optically active, and this one is also optically active. But this racemic mixture means what? It is a mixture of equal parts of enantiomer, mixture of plus lactic acid and minus lactic acid. So this is the what this is the racemic mixture is denoted by this formula. Okay, plus and this minus. So this is what, how you indicate this racemic mixture. It means that it having plus and minus both the enantiomer. Okay, lactic acid, plus and minus lactic acid. So this is in this way you can denote the racemic mixture. The specific rotation is 0. Specific rotation is 0, and this racemic mixture is optically inactive. Racemic mixture is what? Optically inactive. Optically inactive. And the optical inactivity of this racemic mixture is due to external compensation. Is due to external compensation. It means that what your racemic mixture means what? You are having a mixture of two enantiomer, equal parts of enantiomer. It means that one rotate on right hand side and one rotate on left hand side. Okay, and the net effect is 0. The specific rotation is 0. It means that this your the net effect on that digital meter is you will see the 0 reading. It means that this racemic mixture are optically inactive. Okay, and the optically inactive is due to your external compensation. One rotate on right hand side and one rotate on left hand side. Okay, and the net effect is 0. That's why this racemic mixture are optically inactive, and the optical inactivity is due to external compensation. So a mixture of equal parts of enantiomer is called as racemic mixture or racemic modification. A mixture is optically inactive. Racemic mixture is what? Optically inactive. It can be denoted by this sign. Okay, and it does not rotate the plane polarized light. Okay, that's why it is optically inactive. And you can say also said that it is equimolar mixture of plus and minus form. Okay, so this is the how you denote the racemic mixture, plus and minus form of lactic acid. Yes, काय म्हणतो प्लस लॅक्टिक ऍसिड? हॅलो. हाँ हाँ हाँ, नहीं नहीं बराबर है. What here is your one hydrogen is there. ठीक है, it's a missing. ठीक है, it's a CH3. So here you have to correct this. It's a CH3. Hmm? Good, very good. CH3 है. ठीक है, मेल्टिंग पॉइंट का मेल्टिंग पॉइंट एमपी मीन्स मेल्टिंग पॉइंट. ठीक है. Okay, so this is your about your racemic mixture. A mixture of equal parts of enantiomer is called as a racemic mixture or racemic modification. A racemic mixture is optically inactive. It can be denoted by this sign plus and minus. ठीक है, and it does not rotate the plane polarized light. So that's why it is optically inactive, and you can also call it as it is equimolar mixture of plus and minus form. Okay, so the optical inactivity is due to external compensation because one rotate on right hand side and one rotate on left hand side. Okay, that's why the net effect is zero and racemic mixture are optically inactive. So this is all about your racemic mixture. Now the next point is the difference between your racemic mixture and meso compound. Difference between your racemic mixture and meso compound. Okay, so this racemic mixture, it is equimolar mixture of two enantiomer, that is plus and minus. It is equimolar mixture of two enantiomer. While this meso compound, it is a single compound with two or more chiral carbon. Single compound with two or more chiral carbon but has a plane of symmetry is called as meso structure or meso compound. Okay, so racemic mixture means what? It is equimolar mixture of two enantiomer, that is plus and minus form. While meso compound, it is a single compound with a two or more chiral carbon atom but has a plane of symmetry is called as meso compound or meso structure. Okay. Now the second point is it can be separated by method called as resolution. Okay, you can't separate it by physical method, but there is one chemical method you can separate it by method, and the name of that method is resolution. By resolution you can separate this mixture of enantiomer. Okay, and it cannot be separated because it's a single compound, you can't separate it. Okay, it's already separated now, so it's about it's a single compound, so it cannot be separated. Okay, now third point is it has no element of symmetry. Racemic mixture, it don't passes any element of symmetry, don't passes any element of symmetry. Or this meso compound, it passes the plane of symmetry, so in racemic mixture it does not have any element of symmetry, while this meso compound, it passes the plane of symmetry. Now this fifth point. Okay, uh, this racemic mixture are optically inactive, and this optical inactivity is due to external compensation. Optically inactive due to external compensation, while this meso compound, it is optically inactive but it is due to internal compensation because problem in structure, problem is internal while the problem is external. One rotate on right hand side and one rotate on left hand side. Okay, so here instead of this CH2, CH3 is there. CH3, it's a methyl group. So this is the difference between your meso compound and your racemic mixture. So racemic mixture, it is equimolar mixture of two enantiomer, that is plus and minus form, while meso compound, it is a single compound with two or more chiral carbon atom but has a plane of symmetry is called as meso structure or meso compound. So this you can separate this racemic mixture by method, and the name of that method is resolution. And here you can't separate, it can be separated, it cannot be separated. While this uh, racemic mixture, it does not passes any element of symmetry, element of symmetry, that is center of symmetry, plane of symmetry or alternating axis of symmetry. It does not passes any element of symmetry. While this meso compound passes plane of symmetry, it passes the plane of symmetry. Now this racemic mixture are optically inactive. and the optical inactivity of that racemic mixture is due to external compensation. External compensation, okay, because you are having you are having equimolar mixture of two enantiomer. It means that one enantiomer rotate the light on right hand side and one rotate on left hand side, and the net effect is zero. Okay, so the problem is external. So the optically the racemic mixture are optically inactive and it is due to external compensation. While this meso compounds are optical, they are also optically inactive, but the optical inactivity is due to internal compensation, because it passes the plane of symmetry. Okay, so due to that plane of symmetry, this molecule is optically inactive, and we had learned that the molecule which passes plane of symmetry, center of symmetry, or alternating axis of symmetry, that molecule will be optically inactive. Yes, in internal and external. So difference is there, na? So what here in meso compounds are optically inactive. ठीक है, and the optical inactivity is due to internal compensation, because तुमचा तो प्रॉब्लेम तो काय स्ट्रक्चर मध्ये प्रॉब्लेम आहे. ठीक आहे, so problem is in structure. Okay, the optical inactivity is due to structure. Okay, it passes the plane of symmetry. So meso compound plane of symmetry दाखवतो म्हणून तो that molecule is optically inactive, while your racemic mixture, they are also optically inactive, but due to external compensation, because one rotate on right hand side and एक right hand side ला rotate करतो light आणि एक left hand side ला. ठीक आहे, दोघं एकमेकाच्या opposite side ला, and the net effect is zero. You will see the zero reading on that polarimeter. Okay, so this is what external and internal compensation. ठीक है. Now next point is the resolution. Okay, so what is the resolution? So this resolution means the separation of racemic mixture into its two individual optically active components. It is the separation of racemic mixture into its two individual optically active components, that is plus and minus, is known as resolution. Okay, so consider this beaker. Okay, is beaker having your racemic mixture, and you know that this racemic mixture is optically inactive, and you are separating this racemic mixture by resolution. It is one of the chemical method, and it is nothing but the separation of racemic mixture into its two individual optically active components, that is plus and minus, is called as resolution. So by a resolution, you are separating this racemic mixture into plus and minus form, into two separate optically active form. Okay, that is called as resolution. Resolution means what? You are having optically inactive component, that is called as racemic mixture, and that racemic mixture, your racemic mixture means what? It is a equimolar mixture of two enantiomer. And that racemic mixture is optically inactive. Okay, then by this resolution method, you are separating that racemic mixture or that enantiomer into two individual optically active components. Separate करो तुम्ही डायरेक्ट. ठीक आहे, प्लस separate, minus separate, and this plus and minus, now once it's separate, they shows optical activity, and both has plus and minus has the ability to rotate the plane polarized light. So plus rotate right hand side and minus rotate left hand side. This is all about your resolution. All about your what? Resolution. ठीक है. Any question? समझ लो करें. हाँ, हेलो. हा इथं काय नुसतं आपलं हा ऑनलाईन क्लास का आपलं ऑनलाईन क्लास चालू आहे मस्तपैकी. हा सरांनी सांगितलं इकडे समजतंय का? नुसतं येस म्हणा, तसं करायचं नाही, कळलं का? हा. हम्म. हो. काय सगळं समजून घ्यायचं, कारण की इझी टॉपिक आहे हा. इझीएस्ट टॉपिक आहे. तुम्ही जेवढा लेक्चर अटेंड केले ना, तुमचं लेक्चरलाच क्लिअर होईल. व्यवस्थित लेक्चर ऐकायचं. हॅलो. So my question is that, okay, okay, now I will ask you the question. ठीक है? हाँ, mute yourself. Okay, mute yourself. हाँ. Now what is mean by meso compound? What is mean? Okay. Now why meso compounds are optically inactive? What is the reason behind this? Okay. And so the next question is about racemic mixture. What is mean by racemic mixture? हम्म. हम्म. तुम्हाला माहित असेल ते ड्रग आहे लिओडोपा म्हणून, ऐकलंय का? लिओडोपा, डोपामाइन म्हणून, लिओडोपा ऐकलंय का? तो ड्रग आहे ना, ज्यांना पार्किन्सन डिजीज असतो, माहिती आहे पार्किन्सन डिजीज? हा ते काही पार्किन्सन डिजीज असताना, so this levodopa, okay, it is used for the treatment of Parkinson disease, okay, and this levodopa, it is a optically active drug, and when you synthesize that drug, okay, you will get the racemic mixture. Okay, let me show you that. Let me show you that. It is what? You'll get the mixture. What you'll get? Mixture, and you are separating that racemic mixture of levodopa by resolution. By what? Resolution. No. So, का दिसते का रे? दिसते स्लाइड? बघ. ठीक आहे. आता हे सिंथेसिस आहे, बरोबर? इट्स सेम अगं थांब, थोडं दिसेल ते. ठीक आहे. सो व्हॉट? ठीक आहे. नाउ व्हॉट? when you reduce this compound, okay, you will get this DL mixture. You will get what? DL mixture, or a racemic mixture. It is also called as DL mixture because you are having both dextrorotary and levorotary compound. Okay, so this is your DL mixture. ठीक है? Racemic mixture. So next step is you are doing here acetylation, and what you are separating this by resolution. Okay, and this resoluting reagent is alpha phenyl and you will get this levodopa. Only levodopa having ability, अरे म्यूट कर रहे, only levodopa having ability to treat the Parkinson disease. Okay, not D-dopa. So this is the application of your resolution. This is what? Application of resolution. When you synthesize, you will get this racemic mixture, but what? Only L isomer having this activity to treat your Parkinson disease. Okay, so you are separating this TL mixture. So this is your racemic mixture, and you are separating this racemic mixture by resolution, and the resulting reagent is alpha phenyl diamine. Okay, when you separate this, you will get this separate L and D enantiomer, and only this L enantiomer having ability to treat the Parkinson disease, so this is the application of your resolution. ठीक है. ठीक है आता काय. एनी क्वेश्चन. ठीक आहे. आणि काही स्टुडंट, हां हां, सम स्टुडंट हॅव